Okay, AP Calculus, section 3.8, page 4. Let's just start running through some examples with these inverse trig derivatives. Right here, f of x is inverse cosine of 3x. Find f prime of x. This piece right in here, this 3x, that's like the u. That's the inside of the inverse cosine function. So when we find this derivative, the derivative of inverse cosine, first off, it's a c function, so we know it's -1. It's not one of the tangents, so it's not plus. And it's one of the simpler ones. It's just like inverse sine. So that's 1 minus the u squared, 3x squared. It's -1 over square root 1 minus u squared. And then times the derivative of the u times the derivative of 3x, which is 3. And now we just simplify, and we will have -3 over the square root of 1 minus 9x squared. That's it. You do not have to rationalize that denominator. You may leave it just as it is. There's the derivative. Let's look at this next one. F of x is inverse secant of a half x. Find f prime. All right, so here we go. F prime of x. This is secant. It's not a c function, so we know we have a positive one in the numerator. However, it is the more complicated of the derivatives, and that's going to be absolute value of the u. So absolute value of a half x times the square root of, now this, because I put the absolute value of that u piece out here, that means that u squared has to go right here. So that's a half x quantity squared minus 1. There's the u squared minus 1 now, times the derivative of the inside, times the half. Okay, now, have to simplify this mess. So we have 1 over, all right, this absolute value of a half x. Would you agree with me that I can pull the half out and leave the absolute value of x inside? So if you take any number, multiply it by half, then take the absolute value, isn't that the same thing as taking the absolute value of your number first and then multiplying by a half? Absolutely. And then inside of here, if we square this, that's x squared over 4 minus 1 times a half. All right, now look at this. This 2 here in the denominator is going to cancel out with that 2 there. So we have 1 over absolute value x square root, and underneath this square root, I'm going to go ahead and get a common denominator, which gives me x squared minus 4 all over 4. I need some space over here. Yeah. All right, now I'm going to take this 4 that's down here in the denominator, I'm going to factor that out. So that's 1 absolute value x times half square root x squared minus 4. Because when I pull that 4 out, when I factor out that 4 is underneath the square root. So it pulls this half here. Now take this 2 up top. We have 2 over absolute value x square root x squared minus 4. There's the derivative. If you're having some issues with the algebra in here, please come see me or see Mrs. Smith, or go to the Math Resource Center. Come see me or Mrs. Smith during second hour. Somehow, if you're having issues with the algebra in these last few steps, you got to get that straightened out. Okay, look at this next one. find dy dt given y is inverse sine of the quantity 1 minus t. Let's just start doing that derivative. Dy dt, inverse sine first, and that's 1 over big square root. And then is it u squared minus 1 or 1 minus u squared? 1 minus u squared, so 1 minus a 1 minus t quantity squared times the derivative of the inside, which is negative 1. Simplifying, I'm just going to square out this 1 minus t, so that's a 1 minus 2t plus a t squared, and combining some like terms, 1 minus 1's gone, minus a minus 2t is 2t minus t squared. There's the derivative. They are ugly looking derivatives, but they are correct. Next one here, this one. Find dy dx given y is 1 over inverse sine of 2x. We could do a quotient rule, but I think a quotient rule might be ugly. Let's rewrite this and see a chain rule. So if we rewrite y, it would be inverse sine of 2x to the negative 1. Now this negative 1 means something different than this negative 1. This negative 1 in here means inverse sine. This negative 1 out here means 1 over that mess. Let's find this derivative. And we have 3 nested functions here. This negative 1 exponent, outside most, inverse sine, next layer in, 2x, last layer in. All right, here we go. Let's do this. Pull that negative 1 down in front. Leave the inside alone to the negative 2 times, now we've done that negative 1 derivative. The next layer in is the inverse sine. So we'll do the derivative of the inverse sine, which is 1 over the square root of 1 minus u squared, where u is this 2x, and times, so we've done the derivative of the negative 1 power, we've done the derivative of the inverse sine. Now we need to do the derivative of the 2x, which is just 2. All right, cleaning this up, we can kind of take anything that's got a negative exponent and move it down to the bottom and multiply the numerator. We have a negative 1 times a 2 in the numerator, so a negative 2. Denominator is going to be this inverse sine of 2x, that squared. And no, you cannot bring this negative 2 in here and say negative 2, because sine to the negative 2 is not, you're messing around with this, the exponents. You can't. You just have to leave it like this. And then times this square root. That's going to be 1 minus 4x squared. And there's that derivative. All right. Last one on this page. I love this problem. Wait till you see how this one turns out. If y is inverse cotangent of 1 over x, and then minus inverse tangent of x. Let's find that derivative. Dy dx, or we've got some tangents in here. Oh, but that's got that 1 over x. I don't want to do a quotient rule, so I'm going to rewrite this. So I did inverse cotangent of x to the negative 1 minus inverse tangent x. Now I can do a derivative. And the derivative of an inverse cotangent is negative 1 over 1 plus the u squared. This is your u. So that's going to be an x to the negative 1 squared times the derivative of the u. So that's negative 1 x to the negative 2. There's the inverse cotangent derivative. Now minus this derivative of the inverse tangent. It's a 1 over a 1 plus u squared, so 1 plus x squared, times the derivative of the inside, just a 1. All right, let's clean this up. Negative 1 over 1 plus x to the negative 2 times negative 1 over x squared minus 1 over 1 plus x squared. All right, let's multiply these two fractions over here together. The numerator, we get 1. Denominator, x squared times 1, x squared, plus x squared times x to the negative 2. That's 1. Oh, see what I mean? Look at this. 1 over x squared plus 1 minus 1 over x squared plus 1. This is 0. Yes, this is 0. That means that there was a horizontal tangent everywhere. There was a horizontal tangent everywhere. The slope of the tangent line is not dependent on x. No matter what your x value is, the slope of the tangent line is 0. Why? How could that be? How could that happen? All right, let's come back over here and let's look at this. Inverse cotangent of 1 over x. That's saying the spot on the unit circle where the cotangent is 1 over x. Okay, think. If cotangent is 1 over x, then tangent is x over 1, exactly. So this equation really is y equals inverse tangent of x minus inverse tangent of x, which is 0. So I just asked you to find the slope of the tangent line of the x-axis. Okay, groan, whine, complain, it's okay. It was fun though. Thanks for tuning in.